Hello, I am Sarthak Jaria and I have prepared this presentation on file system in Unix, explaining different types of files such as ordinary or regular file, directory file and device file. File in Unix. The file is a container for storing information. As a first approximation, we can treat it simply as a sequence of characters. If we name a file foo and write three characters A, B, and C into it, then foo will contain only the string ABC and nothing else. Unlike the old DOS files, a Unix file doesn't contain the EOF or end of file mark. The file's size is not stored in the file, not even its name. All file attributes are kept in a separate area of hard disk, not directly accessible to humans, but only to the kernel. Unix treats directories and devices as file as well. A directory is simply a folder where you store file names and other directories. All physical devices like the hard disk, memory, CD-ROM, printer, and modem are treated as files. The shell is also a file, and so is the kernel. Unix treats the main memory in our system as a file too. So, basically, files are divided into three categories. Ordinary file, also known as regular file, it contains only data as a stream of characters. Directory file. It's commonly said that a directory contains files and other directories, but strictly speaking, it contains their names and a number associated with each name. Device file. All devices and peripherals are represented by files. To read or write a device, you have to perform these operations on its associated file. The reason why we make this distinction between files types is that the significance of a file attribute often depends on its type. Read permission for an ordinary file means something quite different from that for a directory. Moreover, you can directly put something on a directory file and the device file isn't really a stream of characters. While many commands works with all types of file, some don't. For a proper understanding of a file system, we must understand the significance of these files. Ordinary file. An ordinary file or regular file is the most common file type. All programs we write belong to this type. An ordinary file itself can be divided into two types. Text file. A text file contains only printable characters and you can often view the contents and make sense out of them. All C and Java program sources, shell and Perl scripts are text files. A text file contains lines of characters where every line is terminated with the new line character, also known as line feed LF. When you press enter while inserting text, the LF character is appended to every line. We won't see this character normally, but there is a command OD which can make it visible. Binary file contains both printable and non-printable characters that cover the entire ASCII range from 0 to 255. Most Unix commands are binary file, and the object code and executables that are produced by compiling C programs are also binary files. Pictures, sound, and video files are binary files too. Displaying such files with a simple cat command produces unreadable output and may even disturb terminal settings. Directory file. A directory contains no data but keeps some details of the file and subdirectories that it contains. Unix file system is organized with a number of directories and subdirectories. A directory file contains an entry for every file and subdirectory that it houses. Each entry has two components, the file name and a unique identification number for the file or directory called the inode number. In essence, a directory contains the file name and not the file's contents. The name of a file can only be found in its directory. The file itself doesn't contain its own name or any of its attribute, like the size or access rights. When a file is created or removed, the kernel updates its corresponding directory by adding or removing the entry, that is, the inode number and file name associated with the file. Device file. Activities like printing files, installing software, or backing up files to tape are performed by reading or writing the file representing the device. It is advantageous to treat devices as files, as some of the commands used to access an ordinary file also work with device files. Device file names are generally found inside a single directory structure /dev. A device file is indeed special. It's not really a stream of characters. In fact, it doesn't contain anything at all. Every file has some attributes that are not stored in the file but elsewhere on the disk. Operations of a file is entirely governed by the attributes of its associated file. A kernel identifies a device from its attributes and then uses them to operate the device. Now, let us answer some questions on file attributes. A file was not writable by groups and others and yet could be deleted by users of those categories. How? Like a file, a directory has its own permissions, owners, and links. So, permissions acquire a different meaning when the term is applied to a directory. In the above case, the file was not writable by groups and others, yet could be deleted by users of those categories. This points out that the directory must have been writable by groups and others. The right permission for a directory determines whether you can create or remove files in it, because these actions modify the directory. The term write protected has limited meaning in Unix file system. A write protected file can't be written, but it can be removed if the directory has write permissions. How do you ensure that all files created by you will have the default permission rw-rw followed by 4-, which is also the alphabetical representation of the octal permission 660? When we create files and directories, default permissions are assigned to them, which depend on system's default settings. For example, the default permission for regular files is 666 and for directories is 777. Now, when we create a file or directory, this default is transformed by subtracting the user mask from it to remove one or more permissions. Now, to set the default permission of file as rw-rw followed by 4-, use umask006 in your dot profile. This will subtract 006 from 666, which is the default octal for files. Hence, will give us 660, which translates to the default permission that we require, that is rw-rw followed by 4-. When you invoke ls-l foo, the access time of foo changes. True or false? ls-l displays the last modification time. We write to a file, the time of last modification is updated in the file's inode number. Modification time gets set only when the contents of a file are changed. A file also has an access time, that is the last time someone read, wrote or executed a file. Hence, ls-l foo changes the access time of foo is a false statement, as the access time of a file is not changed by a lookup of the inode. How can you find out whether a program has been executed today? A UNIX file has three important timestamps associated with it. Time of last file modification. When we write to a file, the time of last modification is updated in the file's inode. Time of last access. Last time someone read, wrote or executed a file. Time of last inode modification. To find out whether a program has been executed today, find out its last access time with ls-lu foo. What does the command touch foo do? Why is the command important for the system administrator? Sometimes it may be needed to set the modification and access times to predefined values. The touch command is used to change both these times. So the command touch foo sets the modification and access time of foo to the current time. The administrator uses touch command to change these times. Whenever he finds files to be wrongly stamped, wrong timestamps can result in inclusion or exclusion of a file from backup.